Good afternoon, and thank you all for joining today's webinar from Spec Innovations, Innoslate, the gateway to SysML 2.0 and beyond. My name is Sarah Craig, and I will be the moderator for today's webinar. Let's go over some quick housekeeping before we get started. For those of you who may not be aware, Spec Innovations provides systems engineering services and solutions to the aerospace, defense, and intelligence communities. Our flagship software, Innoslate, provides users with an all-in-one systems engineering software solution with requirements management, analytics, modeling, simulation, and analysis of alternative tools. We help organizations securely collaborate on critical projects throughout the product or systems lifecycle. During the presentation, feel free to send us questions using the panel on the right, and we will get them answered in the question and answer part of the webinar. The webinar is being recorded, and we will make it available to you after the live presentation, so be sure to keep an eye out for it in your inbox. Now, I would like to introduce you to our presenter, Dr. Stephen Dam. Today, Steve will be showing you how Innoslate provides most of the features of SysML 2.0 today, and will easily transform into the full SysML 2.0 implementation once it's available. Dr. Dam is the president and founder of Spec Innovations. He has been involved with research, experiments, operations analysis, software development, systems engineering, and training for more than 40 years. Dr. Dam participated in the development of the C4ISR architecture framework and DoD architecture framework. He has also received an expert systems engineering professional certification from INCOSE. He currently is applying systems engineering techniques to various DoD, DOE, and commercial projects. And now I will hand over the controls to Dr. Dam, and we will get started.
Thanks, Sarah. So today, everybody's interested in SysML, of course. It's a major tool that's being used in the systems engineering community. So we're going to talk a little bit about what is SysML today, how do we currently support SysML, and then get into the plans for SysML 2.0. And I will rely heavily on a briefing by Sandy Friedenthal that he gave during the INCOSE International Workshop. So there'll be obvious annotations to his slides and what he was talking about. Then I want to talk a little bit about how we plan to bridge the gap between 1.6 and 2.0, and then also how users can transition and gain the advantages of LML today without losing what they have in SysML. So what's SysML today? Most of you are on here probably aware of this, so I'm preaching to the choir, so I'll keep this short. So basically, SysML is a profile on the Unified Modeling Language. It is basically developed by the nonprofit object management group, is the ones orchestrating this. So a consortium of a large number of companies and corporations and organizations. They're currently in version 1.6, and that specification is nearly 400 pages. Now understand, this is 400 pages for 9 diagram types. So it's a lot of pages to express what's needed. That's okay. The IDEF 0 specification was 100 pages by itself. So that's not unreasonable, actually. That's about what it takes to actually describe one of these diagrams completely. So SysML 1.x is focused on the development of systems models based on a graphical ontology that employs this set of 9 diagrams. And the idea was these were general purpose modeling language for systems engineering. That's what they were trying to create for this SysML. Again, basing it off of UML, it's more of a software focused approach, but that's okay. That a lot of our work came from the software world. IDEF did, many other languages and developments in the systems engineering world came from the software engineering world first. It has the intent to specify a language so systems modelers may learn and to apply and use SysML. Okay, these are quotes out of the specification, so that modeling tool vendors may implement and support SysML. Okay, so the whole idea was, here's something that the vendor community could go off and take and work with and have interoperability even between the tools. That was, of course, part of the goal of this. Unfortunately, being a graphical ontology, the tool vendors have implemented SysML in various ways. So interoperability to the tools is currently very difficult. There's a project INCOSE has currently out of the automotive working group where we're trying to figure out how to move data between various SysML tools, and found that it was extremely difficult, and nothing came across 100% from one to any other tool. Now, XMI was supposed to help fix this problem. This is again an extensible markup interface language. It's an XML-based approach, and that would have been great as a means of exchange. But since they didn't standardize the XML tags, guess what? Every vendor implemented it differently. So now you got the Tower of Babel problem. And of course, the other problem there is that the vendors do not document this very well. So that now you really are struggling. If you're serious about trying to interface with these tools through XMI, it's quite a struggle. I'll talk a little bit more about when we get into LML Innoslate, a little bit more about the problems we ran into specifically on that. So if you look at the current diagram set for 1.x, it's these set of 9 diagrams, and you can see some of them were inherited from UML, some of them are modified from UML, and some are new diagrams. Actually, only 2 new diagrams came into this being for this purpose. Again, the idea was to make it so that you're capturing the systems engineering information you need to do your job as a systems engineer. But unfortunately, again, coming from this more software perspective, they didn't really take the approach of understanding what we do as systems engineers. We optimize cost, schedule, and performance while mitigating risk in each area. That's our job, okay? That's a fundamental thing that we do as systems engineers. We also have to communicate with all the design engineering community. So we optimize across the whole set of designs. So we have to be multilingual. We have to be able to speak all kinds of different languages. We can't ask everybody to come to use our language either. That's a big problem with SysML. A lot of people are trying to teach SysML to the other domains, and they're not getting a lot of great response. Let's put it that way. Okay, so if you're going to do all the things you really need to do as a systems engineer, you're going to have to add that information in really what are ad hoc ways. And so since there's no standardization for that, it makes it very difficult. By the way, I want to do a shout out to my buddy Jerry Sellers. He has some of these little icons, these little graphics on the side here. So he popped those in for me, a little bit of a help. So. He is a lot more expert in SysML than I am, which is part of the reason I wanted to give him credit. So they grouped the different diagram sets into 4 pillars: structure, requirements, behavior, and parametrics. And the requirements, parametrics pillars are really just one diagram each. So it's kind of an interesting way to look at it, but that's how they talk about it. So some of the pros and cons about SysML 1.x. So I think most of you know this. Again, it links to UML for software-centric systems. I mean, if you're going to do a software-centric system and you're dealing with software developers who are using UML, which, oh, by the way, a lot of them are not, then it might be a good communications tool for that purpose. It does provide standard diagrams across a number of the systems engineering disciplines. Particularly, they added in the requirements diagram, the parametric diagram, specifically for the systems engineering domain. And SysML is encouraging the whole concept of model-based systems engineering, which I'm all for and actually have been doing for over 30 years. We didn't call it that before, but we used to call it computer-aided systems engineering, or CASE, with an underline under the SE. And so it's nice that we have new names for things that we've been doing forever, but that's okay. I'm happy about that because it does force people to think about the problem a little bit more in a database approach, in a model-based approach. So what are the cons? Well, first of all, it's an extremely difficult language to learn and accurately create accurate diagrams. There are several books on the subject. In fact, there's 2 classic books, and I forget the authors of the 2, but you have to kind of do the 2 of them together to get really this real knowledge and capability to use it effectively. And it lacks the ontological basis. That's the fundamental, verbal. The way we communicate is often verbally written, so it was missing that. And of course, that's part of what the recognition is for is a problem with SysML 1.x, which is why they're trying to deal with that in SysML 2.0. Now, again, users and vendors vary significantly on how the language is implemented in tools. I have a great example of one where an expert in SysML developed a diagram, and I got it to see if I could put it into Innoslate, and I struggled with it. I didn't understand what the diagram was telling me. I mean, I'm an expert systems engineer. I've got over 40 years of experience. You know, I should be able to understand this diagram, right? You think. Well, a friend of mine who was also an ESEP came over, said, oh, I understand it real well. I was there when they talked about it, so he came over to explain it to me. And after about an hour, we realized we didn't understand what that diagram meant. Now, that's bad. Now, you think about that, that's real bad, because if experts can't understand what the diagram means, how are you communicating this to everybody else? That's a big, big problem, okay? So just be aware of that with SysML. Well, let's see, how do we support SysML today? Oh, yeah, one of the important things is actually LML 1.1, version 1.1 was released in 2014, and it defined an ontology for SysML way back then. We've been using that for many years, and it's been available for a lot of other people. There's a claim by some other vendor that they use it as well. I have seen it used in other ways by hand by people, but it's been out there and available. Okay, so specifically LML. What is LML? So lifecycle modeling language, if you're not familiar with it, is an open source standard. It is not owned by anybody. A lot of people say it's proprietary to Spec Innovations. No, it's not. The guy who chairs the committee is a Naval Postgraduate School professor, okay, former retired Navy captain, okay. So no, it is not proprietary to Spec Innovations. And right now it has been taken over by a lifecycle modeling organization that was created, called a not-for-profit organization, to steer the standard and to move forward other things in this domain. So the original SysML LML specification was developed back by the LML steering committee, which has now been subsumed into the LMO, back in 2012. And right at that time, it didn't contain any specified classes for SysML. So you know, a lot of people said, well, yeah, you really have to tie it to SysML because SysML is the current thing. We did tie it to the DM2, which is the DODAF Meta Model 2.0, to make sure we met the DoD things at that time, but we hadn't really tied it back to SysML. So the committee realized that was needed to be worked on, and so we spent another year or so working on that. And finally, in 2014, we released version 1.1 of the standard with the extensions for SysML. What we added was a port subclass, so we could support particularly the IBD. We added an equation class to support the parametric diagram. And of course, a number of relationships and attributes were needed to connect the information to make sure it met the specification at the time. No modifications have been made to an LML specification since 2014 because it was really determined that LML was designed to be as simple as possible, kind of that irreducible set of information you need to capture, and then allow the users to extend the ontology. In fact, we call LML the 80% solution. We know that you're going to capture additional information, you're going to want to extend the schema, and then it allows you to do that as you need to for your project or your organization, and doesn't force you down a path that's not appropriate. Of course, that requires the software that deals with this to be much more flexible and much more adaptable as well. So SysML diagrams in the Innoslate, these are the different diagram sets. We do not have every bell and whistle in 1.6. I will tell you, we have not touched this in years, these diagrams. And so I heard some things just the other day where there's some things I think we're missing. And again, if people are interested in us adding those kinds of things, we always welcome that input, and we always look forward to having people give us insights into things they're using or want to use that we don't have. So again, Innoslate, pros and cons. Well, first of all, it covers a greater breadth of systems engineering disciplines. We do cover the entire life cycle for systems engineering and program management, by the way. It is ontologically based. So in other words, the data in the database and the rules for the view you're looking in are automatically connected to each other so that you see that information in many different forms. So if you take a diagram as an activity diagram, you can turn it into the LML action diagram or an n-squared chart or an IDEF0. Okay, again, all that's doable within the tool because we just follow the rules for the diagram. And of course, the other thing is we actually enable physically constrained functional model execution through a discrete event and Monte Carlo simulation capability. Now, those are actually very important because the kinds of things we do in systems engineering, we don't know the actual numbers exactly. In fact, you rarely know numbers exactly in reality, right? So having Monte Carlo particularly was a big aha to me because that was something I didn't realize. I'd been using a tool with a discrete event simulator for many years, but the Monte Carlo is just critical to what we do, and I just had never appreciated it until we actually built one ourselves. Anyway, it's a lot easier to learn and apply. We found, in fact, that people can gravitate to the Innoslate very, very quickly and to the LML very, very quickly. In fact, to learn LML, there's a very simple, very thin guide. It's maybe about 30, 40 pages that's available on Amazon called Essential LML. Take a look at that. You'll get some real insight into how simple and easy this really is to pick up and learn. If you want a more in-depth, I recommend my real MBSE book. Gets into that in a lot more depth. Extensive use of natural language processing technology is another thing we've done with Innoslate. That's really important because we operate in natural language. That's what we do. And English, in fact, which is kind of nice, is really almost an international scientific recognized language. So it basically forms the basis for an awful lot of things around the world, not just here in the United States or just in the English-speaking countries. So it is available, and most people do gravitate. So having that ability to take and process that information, use it to make decisions and create things. For example, we use NLP to check quality of the requirement. Is it clear? Is it complete? Is it consistent? Things like that. So, these are things that really help you do a better job. So if you're not familiar with NLP, it is a branch of artificial intelligence. Everybody hears about artificial intelligence. Well, that's what NLP is. It's really designed for that purpose, okay? So it's here to help us do better. And of course, we are looking into machine learning and some of the other aspects of AI. Okay, the other thing is it's cloud native. It was designed for the cloud from scratch. Okay, so back when we first were doing the development was 2010, and we ran into a presentation by Dr. Mike Ruskevich. Well, Mike R. was the chief engineer at NASA at the time. He was going around with this briefing to show people and say, hey, this is what NASA wants and NASA needs for a tool set. So we actually took that as our basis, and particularly one of the key things was scalability. And the only way you could scale to millions of objects, particularly at that time, that was 11 years ago, was cloud. And we knew that the cloud was coming, and so we were early adopters of the cloud. We were on the Google Cloud platform for many years until they sort of abandoned the US government to a great extent. And so we're on the Amazon cloud as our primary cloud. We're also on Azure. So we are very cloud native. Okay, but that actually makes it easy to go the other way, client server or desktop technologies. We actually have implementations for both. It's called enterprise and it can be deployed those other places. The bad part about desktop technology, of course, is you start losing a lot of the collaboration features and things like that you have on the cloud or client server. So we don't recommend that as much. But if you need a standalone, that's even feasible. Okay, so cons. It doesn't really completely represent the current SysML standard. We know that. We've looked at it. Again, most people do not use our tool as a SysML tool, but if we get more people who want to use it that way, we'll be glad to add those features that you're used to using and that you need to make it better. not a problem. No XMI export, again, that's just a request. Again, if we know what the format is, what the tags are, what you're trying to get to, that was a big problem for us, because on the we have 3 different tools we can import from in XMI. It's Magic Draw, let's see, what's Enterprise Architect, and then Rational Software Architect. Okay, those 3 tools. And we had to write 3 different parsers for 3 different tools, because again, those XML tags are not standard. Oh, and the way we were able to do that was we got examples of this from these different tools and reverse engineered it, because they don't make it available, unfortunately, in an open way. Again, if I'm wrong in that, I'd love to be corrected. And if you've got a link that shows me how each of those tools develop XML, please send it to me. I'm, again, don't know everything that's going on in the world, but at least that's why I'm told where we are right now. Another thing right now is we do not have a state machine execution engine. We've been pretty happy with the discrete event Monte Carlo capabilities we have with the functional modeling that we do in the action diagram, which is again similar to an activity diagram. And you can translate a state machine diagram into a action diagram as well. In fact, we highly recommend taking that approach. I remember working with state machines, oh gosh, it has to be at least 35, 40 years ago, and being very discomforted with using it for systems engineering. Yes, systems have states and modes and all that kind of stuff, but I just find that that's not as amenable as the functional modeling that we can do with the action diagram. So just that's me. Anyway, so what are the plans for SysML 2.0? Okay, so first of all, SysML version 1.7 is still in progress. Now, what they're going to do with that, I don't know, and what the changes are, I have not been tracking, so I can't tell you. But this is from a presentation again by Sandy Friedenthal. He gave at the International Workshop, so I'm taking from the slides. So I want to make sure that most of the information I have here is reflective of what he presented to the group back then. I didn't hear it, I saw the slides, so I'm getting a lot of this from that and some backup information from people who did listen to it. Again, the plan is to release, I'm sorry, the RFP was released back in December 2017 for version 2. There's a prototype release plan for the fall of 2021. I think it's like August is what they're shooting for. The first full release apparently is not till 2022. So we got a little while. It's not clear how quickly people will pick up the beta version, given that there might be significant changes between the beta version and this full release. Don't know if there's any significant things that are going to happen there, but that's, again, vendors are kind of risk adverse in that regard, because they only have so many resources. Doesn't matter how big you are, you only have so many resources you can devote to something. And so you're going to devote them to the things that are higher priority for people. Some of the key elements of this group, and this is, I think, one of the 2 groups I believe that is planning a submission, is this SST group. They're planning a new meta model ontology. They're planning new visualizations and standardized APIs. So again, those all sound like good things, and if they can do that, that's great. I'd be excited for that, because that would help us actually interface with them better. So I'd be happy. So looking at their 2.0 language capabilities, so they have a code-like representation. You can see it here in the slide at the top. At the left there, that what looks like code, it says package, part, attribute, that looks like code to me. It looks a lot like Java in a lot of ways. And that's supposed to be able to translate and create this diagram to the right automatically. I assume you should be able to go backwards as well. I don't know why you wouldn't be able to, so you should be able to go both ways. So again, that automatic diagram creation is a great idea, not a problem. But having to learn a new code, not sure I want to do that. I certainly know that most of my customers do not want to do that. So I got to wonder about that one. Well, we'll see. And then so again, they're using something called kernel, and I'm still understanding more what kernel is. Is to give the declarative semantic base elements modeled using kernel. So whatever that means to you. That's great. But what was exciting to me, again, they're looking at REST, HTTP APIs, as well as Java and OSLC, which is great. That's all good. And then supports change impact assessment. So I like that one. That's very interesting to me. And I'm really looking to see what is they're doing, how are they doing that methodologically. What we have as a spider diagram for that purpose. And the idea is if you've changed an object in the database, anything it touches and the things that those touch down the path could be impacted by that change. Now, there's only so much you can do in terms of highlighting where the problem might be, because it can be any of those things it's touching. Okay, so it's not simple. This is not a simple thing. So I'm kind of looking to see what kind of algorithms, things like that they're coming up with for doing this change assessments, impact assessments. Okay, the pilot implementation's out there and available, by the way, for you, and they're using a variety of tools. You can see it's a long list of tools they're putting together to do this. I'm assuming that what any vendor would do is it would be to either subsume those underneath their platform so it's transparent to the user, or they would provide some simple mechanism for that. Otherwise, you've got another Tower of Babel going on here where I've got all these different tools I got to deal with as a user. No, thank you. I have enough tools. I mean, even with Innoslate, I have many other tools I use on a daily basis. So I, can't deal with that with it. But again, here's where you can see the use of the APIs coming into play and how they play. So if you want to see that and look at that, it's on GitHub. It's systems modeling / SysML v2 release. And the reason I say that, if you want to copy that down, I believe the slides will be available, or certainly the video of this will be available, so you don't have to write it down. But if you forget, but if you wanted to go to it right now, you could go write that down, hopefully. So again, you can see some of the information. There's a programmatic authoring environment, a graphical authoring environment, a textual authoring environment. So 3 different ways to interact with it, and then the APIs to let you then tie into the databases and structure. This looks an awful lot like Innoslate's structure, by the way. We use what's called a modular systems approach architecture. So what that is a very layered kind of thing like this, where the databases are now separate and can be addressed directly if need be. So how can Innoslate LML bridge the gap between SysML 1.x and 2.0 starting today? Okay, so first of all, if I contrast the differences between SysML version 2 with Innoslate today. So here's the set of things where they contrasted version 1 to version 2. So let's take a look at those. So systems engineering concepts, design and meta model versus add-on, consistent use of definition and usage pattern, more consistent terminology, ability to decompose parts and actions, things like that, of course. Yeah, we do all that already today in LML and Innoslate. Particularly decomposition, every object can be decomposed. So however you want to do decomposition, it's fine. Every object is designed for that purpose. We have a consistent terminology. It's well defined in the standard of LML, and it's implemented and well documented in Innoslate and its users guides. Again, consistent definition and usage all the way through. We try to give you even views having consistency. We have view frameworks we use for that purpose to help you guide you and work through things easier. And of course, all the concepts you need, okay? So into one meta model, it's not an add-on. So we have no add-ons. We have no plugins to our tool. Okay, so more precise, let's walk through that. Yep, we have all those textual syntax, expression language, got it, formal semantics, requirements as constraints, and reified relationships. So again, got it all. Thank you very much. And then more expressive. Again, if you look at the modeling, what we have is much more expressive already. We have a variety of different modeling types that are available to you. Do you want to see different, same information in different views? You can easily go right between them. We do have analytical capabilities as well. Again, the discrete event Monte Carlo simulator give you all kinds of analytical capabilities. We also have the soft analytics using NLP. We have an actual what's called intelligence view, which takes 68 modeling heuristics and looks for best practices throughout your entire model. So there's all kinds of things in there that help you with that. That's actually some work out of Naval Postgraduate School, which we adopted some research there and applied those NLP checkers for that. Trade-off analyses, of course, we've been doing those for years with the tool. Individual snapshots and time slices, yes. And in fact, we're doing some things that'll give you even more capability in that direction very soon. More robust quantitative properties, vectors. Now, you can do vectors in Innoslate. It's just not as simple as perhaps we'd like it to be. So I'm again looking into that one a little bit and see if we have that. And query expressions, though, are very robust in the tool. In fact, we just added a new search engine front end that would help you use the search capability much more helpful in the database view. So that's another good thing with our search capability. Again, with when you're designing for millions of objects, you are going to make sure you can search the database to find things. You have to. More extensible. We found it's very extensible. We've had no problem with extending this to all kinds of different domains and mapping it to things. We've mapped it to UAF, for example. We already have a DODAF interface in terms of the DODAF dashboard. We could create a UAF dashboard probably in a matter of weeks. It's pretty straightforward to do. But again, there has to be a need for it. We have to have customers that are driving towards these kinds of things. And then more standardized APIs. Well, of course, we have standardized APIs. They're available. It's open. You can do all kinds of work with our Java APIs. If you have enterprise, by the way, we do offer the JavaScript APIs as well for you for the user interface part. Okay, so SysML 2.0. Good news, bad news, and great news. And I will give Jerry, again, credit for this slide to a great extent. So SysML 2.0 addresses many of the current limitations and uses a radical approach that basically rewrites the language from the ontology up. It's good. So that's probably good. It probably needed to be because, again, it's a software engineering language that's being translated into a systems engineering language. Let's relook at it from a systems engineering perspective. That's a great idea. SysML 2.0 will greatly expand the ability to model different aspects of systems engineering not currently well supported. Yep. Again, V&V, if they're going to add in V&V, that's great. We've had V&V in Innoslate for, I don't know, 5-6 years now. We've had Test Center. And SysML 2.0 will support other diagrams beyond the current 9 as diagrams and will be re-rendered from the data. Oh, the way Innoslate currently does it. Great idea. We've been doing that again since day one that we came out there. So that's great. Okay, so the bad news. So while OMG promises there's going to be a smooth transition plan between the two, it's hard to imagine how, if you use any kind of done any kind of major software upgrade, it's never flawless. And as Jerry's pointing out here, is even if it's 99% effective, you have at least 100 flaws in a medium-sized 10,000 element model. Okay, 10,000 elements is nothing to have in one of these models. I can have 10,000 requirements in a single document in some of the projects we're working on. So that's nothing. So the flaws could be hours to find and fix for that kind of thing. And that's the difficulty. It is a very difficult job to translate things between tools. Now, currently, SysML 1.x experts get to learn what is essentially a new language. Blocks are now parts, activities are now actions, et cetera, et cetera, et cetera. Okay, very confusing, frankly, to do that to people who again currently using it. So, but the great news is you can start transition today with Innoslate. So how do you convert starting now? Okay, first of all, our suggested approach is, since LML and Innoslate already provide that broad, flexible ontology you need that gives you the breadth that already will encompass most of what's in SysML 2.0, or at least what's projected from what we can see is going to be in SysML 2.0. And again, you have the visualization for the 1.x diagrams. You can start transitioning your models to Innoslate today. You don't need to wait 2 years to get started. Do it today. The integrated systems Innoslate analysis tools will help you make sure the models are properly developed. You can do executability using the discrete event Monte Carlo simulators. Again, so you can make sure you have a good model. That's, again, I hope all our goals. Because you know, if you're putting errors in the model early in the life cycle, you often don't detect them until late in the life cycle, sometimes not until operations and maintenance. And then you're in big trouble when you find the logic error that should have been caught at the very beginning. Innoslate has proven to be multilingual. We're happy to do that. We want to support all things that we've talked about. BPMN, for example, is another one to look at. Again, don't know how many people want that, but it's okay. So eventual translation to a new SysML 2.0 code like text language, once it's fully defined, should be an easy transition for us. We'll just do the mapping and create the code. And, it's not that hard to do. And again, we already have the REST and Java APIs, so we have at least that part of it. We don't have the OSLC APIs. That's something we're investigating and looking into a little bit more. Again, we haven't seen a driving need for it, but if somebody's got that, let us know, please. And then mapping to the new SysML APIs will also be really straightforward. I mean, we just did this with the APIs for MATLAB, SDK, and GitHub. We're doing it for a half dozen other tools right now that we're looking into and working with. So it's really not a problem for us. When time comes and we need to tie into other tools through this mechanism, we will be thrilled. We will be glad to do that. Again, get all the planned features of SysML today, not 2 years from now. You can write out the transition to SysML 2.0 in comfort and security of Innoslate. So what do we already provide for systems engineering that you need today? Well, we have a documents view, so you can actually author all your documents as if they were objects, but just like you would in Word to a great extent, except now they become objects in the database. They're traceable, they're reusable. You can use cross-project relationships to tie them between different projects within an organization, an Innoslate organization. So this gives you a very robust capability. We use this all the time on our contracts. We do all the work collaboratively in Innoslate, and then we have docx output. So direct docx output, spend maybe an hour or so with the docx cleaning up, adding some headers and footers, using their table of contents features and things like that. Again, we're not a word processing tool, not trying to be a word processing tool. That's not our job. That's what Word is for. Word is a great publication tool. When you want to make it shelfware, you use Word, okay? If you want to have an interactive model-based document approach, use Innoslate. Now, a special type of that is requirements view. So what requirements view gives us is brings in our quality score and some other information about the requirements. Specifically, requirements have different attributes associated with them that are specific. It also brings in the traceability relationships and things like that. So that's very valuable for that purpose. So again, that's something you work with. So that quality checker will create this quality score for you. We also, of course, have modeling. We have, I forget where we're at now, is it 26 diagram types and counting? So not 9, not just the 9 SysML, but 26 different diagram types and counting. And we will continue to add them as needed. We want to make sure you can represent the information in any way you need to communicate it to your customer. I mean, we can't be Visio, sorry, we're a model-based tool. We have limitations, we're not Visio, we're not a drawing tool. When you want to do drawings, use Visio. Actually, if you want to do real drawings, you use Adobe Acrobat. That's another story. That requires an artist to do. So we don't recommend that for everybody. But for your usual presentation like this, it's written in PowerPoint. Perfectly fine. Love PowerPoint. Been using it since version 1. Okay, we also have an updated CAD viewer. We just added in 4.4. So this now brings in your color, your transparency, things like that. This happens to be, this is the, I'm trying to think, this is a zip file. So this is the combination of a .obj and a .mtl file in a zip format that you upload, and then it will let you see the view and things like that. Again, the purpose of the viewer is to see the information that the CAD developer did use. It's not to interact with the CAD software. That's not our job as systems engineer. Our job is to look at what they've done, evaluate it, see if it meets the requirements or not. Simulation, again, I meant that we show it here on the right side of the V, but that's when you've got your models well calibrated and you're ready to use them to do predictive analysis and do V&V. Of course, you can use those same simulators early in the life cycle to help make sure you've got your logic errors out of the problem. You can use the Monte Carlo to help you look at the range and the potential risk of things of what you're developing. And then last but not least on this side is Test Center. So Test Center gives us our test suites, our test cases within the suite. They have expected result, actual result, status. We do status tracking and roll-ups. You have a setup. So it's a very, very valuable way to do your test, capturing your tests and your test information. We are working on interacting with other tools through that. We have a prototype of a Java web app between Test Center and Selenium on the software side. We're hoping to do the same thing with LabVIEW in the near future. Well, of course, you can't forget the program management side, but what about risk analysis? Yep, you got to do that. And oh, by the way, of course, who's responsible for technical risks and identifying the technical risks? That's systems engineering. And of course, timeline analysis. You want to understand the timeline impacts of the system on that as well. So we have a timeline diagram that interoperates as well with our action diagram. So and other functional diagrams. So there's an interactivity between the two. And we do cost analysis, work breakdown. So we have cost as an independent variable. You create the work breakdown structure associated with things, tied into the modeling and the simulation. And guess what? You get actual cost information as well as the timing and other kinds of resource information. So another thing we're doing is developing this digital engineering environment. Innoslate's kind of the core of that. We're looking into a variety of tools. We've done some integrations already. Like I said, GitHub, STK, and MATLAB are already in the tool. The CAD viewer update was done. Again, if we need more in-depth view with CAD, if you want something direct ties and be able to move data between CAD tools, unfortunately, there's a lot of CAD tools out there, and we don't have them ourselves. But if that's something you're interested in, and you want to learn how to use the APIs, or you'd like us to do the APIs for you between them, and be able to move data between them, that's feasible too. We already do have the ability, if you upload a .obj file by itself, you can decompose it into its elements as create entity assets within Innoslate that you can then link back and see if they met the requirements as well. And we're looking at Selenium and LabVIEW I mentioned. Another thing we've been exploring is the HoloLens, get that mixed reality kind of thing. The HoloLens itself actually works with Innoslate today out of the box to a great extent because it's a web-based interface, so you can pick up and bring the web, and in fact, quite a bit of the diagrams interact and things like that pretty well. The problem we had was that nobody could have it on for too long. It looks like a great tool, but it's not quite there yet. Also, voice translation is another thing we're looking into and investigating. So that's our goal, though, is let's make sure we do the systems engineering in Innoslate and program management work in Innoslate, and then interact with these other design engineering tools appropriately. In other words, passing in the minimum data back and forth possible, because what you want is to be able to take data and turn it into information. So, for example, one of the things we are going to be putting very soon into GitHub viewer, we have a viewer and we can push requirements down. What we want to do is take the software and create class diagrams from it. We already have a prototype of it. It's already ready to go. We just didn't quite make the implementation for 4.4. We hope to make it for 4.5, our next release. So coming attractions, and I already started that discussion. So branching and forking, that's actually already in work and under development. We also have some major upgrades to the simulators and the action diagram on our main list. We have quite a number of other things coming in. Another thing we're looking at is natural text-to-lang graphics. So being able to take maybe a process or procedural diagram and create an action diagram from it or something like that. So we're investigating that. Software to diagrams. Yep, that's what the thing I was talking about. Take the software and create a class diagram for that. Again, I already have a prototype for that. Enhanced program management capabilities. How do you like a Kanban board? Yeah, that may be coming soon. A few other things for program management. How about enhanced EVMS capabilities? Exciting. And of course, enhanced modeling simulation. That's of course a major part of what we do. Okay, so I think that's all I have for slides, and we have 15 minutes for questions. So hopefully there are a few questions out there.
Yep, thanks, Dr. Dan. We've already received a few questions. If you haven't done so, please send your questions to the panel on the right. Feel free to ask as many questions as you have, and Dr. Dan will answer as many of them as he can before our time is up. So our first question is, what would be the best approach to migrate models from SysML tools to Innoslate?
So I think one of the things we found is, again, you could try the XMI as a first step, see if that helps you. Another thing would be try CSV. I know that Dr. Sellers has said many times that CSV can be moved fairly easily. Again, that requires you have a lot of metadata and things like that. What we find though is a lot of the diagrams, like the activity diagrams and things like that, don't have a lot of metadata in them. There's boxes with titles in them, not a lot of information to gather. We find that that's probably better just to go ahead and migrate by hand. You'll learn a lot by doing it. You'll have a better model, and that's probably worth the time because you're doing analysis as you go. You're not just moving data around. Be very careful about just moving data from one tool to another tool. You will have you run into the problem of garbage in, garbage out. Okay, and so let's watch that one. But so like I say, we found that, like I say, sometimes moving it by hand is the best thing to do, not just the right thing, not just the easiest thing to do. Next question.
Thank you. Our next question is, what is the status on analysis toolbox integration? Will it work for both cloud and enterprise?
ANSYS. So what will happen? Yeah, right now we're looking at that. We just are developing a relationship with the ANSYS Corporation to get into their tools and working with them. We've done some preliminary work with it. We think that's very doable. They have a tool called Minerva, which is an interface capability that maybe we'll go directly to tools. That's why if there's a kind of nuance on that diagram I showed earlier. We could be going through the Java web app. We might go direct. Don't know quite exactly what we're going to do yet. So it just depends on how that works. Don't know if the cloud will support this or not. Most of these tools, again, like that, are desktop tools because they require a specific kind of processing capability, things like that. They're not really designed to operate in a cloud environment. So again, any cloud-based tool, it's usually pretty easy. We usually have, open APIs to be able to move the data back and forth.
Thank you.
Next question.
Our next question is, are you open to user requests for updates to improve your SysML capabilities?
Yes. I said that a few times in it, but I want to make sure that we foot stomp that. That's something that's really important to us. We are very user-driven, user-focused. There's a feedback form on our dashboard for that purpose. There's a feedback form on our contact page. Please feel free to make suggestions, ask for things. We come through with a lot of stuff, so that'll really surprise you how quickly and interested we are in your inputs and how to make it better.
To what degree will Innoslate be SysML 2.0 compliant? Innoslate doesn't seem to be fully compliant with SysML as of right now.
Well, I will say it really depends on how much SysML is adopted. SysML 2.0 is adopted. If it's adopted heavily, then yes, we'll put a lot of work into it and make sure that interface is very clean and as compliant as possible. Again, can I promise you it'll be 100%? I hope so. But again, it just depends on how well the standard is written and how much people are actually adhering to that standard, and how much we can adhere to that standard. That's always a problem. What's reality?
Thank you. Our next question is, what SysML stuff is missing from the Innoslate implementation?
I don't know. I don't use SysML. I've never used SysML. I've never liked UML. I've never liked any of those things because those are software engineering languages to me. Systems engineering language is, I've used things like RDD 100. I've used Vitek Core. I've used Cradle. Those are more in what I see as systems engineering based tools. So I feel more comfortable with that. I explored some of the other tools over the years, but it just, every time I've tried to get into them, I just couldn't. It seemed unnecessarily complex. My PhD's in physics. And so the reason I like physics is that in one way it's simple, in that we have very simple equations like E equals MC squared. Now they do represent a lot of things, but it can boil down to things like F equals MA too. So we like that. We like the, I guess, elegance maybe is what the term we're looking for, because that simplicity is important for communications purposes. I can't, you think about Einstein's brilliance. If you had actually looked at E equals MC squared, if you saw what it looks like, it's actually E equals M0 C squared divided by the square root of 1 minus V squared over C squared. So, that's not as elegant. It's not as nice looking. So he redefined the rest mass as M0 and that the relativistic mass being M. And so E equals MC squared makes it an elegant solution.
Thank you. Our next question is, have you seen a large adoption of LML by industry and academia?
Yeah, actually we have. We have over 200 universities around the world. We touch at least on almost every discipline that uses systems engineering. So there's been quite a bit of acceptance of it, because once they realize how easy it is to understand and use, they go, oh wow, why was I doing it the hard way? So.
Thank you. Our next question is, what is your philosophy on moving data between tools?
My philosophy personally is to keep it to a minimum. Try not to move the data, because the problem you get into as soon as you start moving data around, now I have a copy of a piece of information. I have two different databases. I then have to configuration manage that information. Okay, and I don't know about you, but I've got too many things to keep straight during a normal day to try to deal with all the information that we're going to be capturing in a database, and where I'm having to do all the configuration management. I'm not a happy camper. That's why we do the view generation from the data, so that every view you see is derived from the data in the database. Core does that, Cradle does that, we do that. Those are the three tools I know that do that regularly and easily. I understand you can do that in Magic Draw, but you have to set it up exactly the right way to be able to reuse information. But I know if you would just add a piece of information to the database or to a diagram, one diagram, and it belongs on other diagrams, it doesn't automatically show up. That means you've got to keep control of that configuration yourself, or you're not portraying the same information, and that's a problem. We've had a number of people say, well, can I hide that information? And the answer is no, because if I allowed you to hide that information, it would make it so that the diagram is inaccurate. It wouldn't reflect what's really in the data in the database, and that's bad practice. So no, or at least as little as possible. That. Do we have any other questions?
Yep. Do we use Innoslate to develop and manage ontology?
Yes, we do. Actually, we use it to develop our own. We actually create class diagrams very often. We also use spider diagrams for that purpose. So a variety of different ways we use it for that purpose. I've actually been wanting to add an ERA diagram because I'm kind of old-fashioned in that regard. So entity relationship attributes, kind of the meta model for all these languages. That's pretty good. We've also, by the way, linked LML to BFO, the basic formal ontology. So we have that linkage as well. That was also mapped by, I believe, Idaho National Labs and some other people. Next question.
What makes moving models from SysML tools difficult?
Again, it's that lack of publicized information about the tags in XMI, I would say, is probably the biggest problem I've run into. That and the standards, the lack of everybody having a real solid standard. You know, it's like for power, right? You plug into a 110 socket, and those power plugs work everywhere. But you go to another country and they have a different standard, and you have to have an adapter and things like that. Sometimes even transformers. And so you got to have a standard if you're going to move things in between and work together. And that's part of why we ended up building Innoslate, because we got frustrated with the fact that the tool vendors really didn't want the tools talking to each other. They wanted to create their own ecosystems. So yes, we created our own ecosystem, but we're trying to keep it as open as possible and ontologically easy for people to extend and work with and do what you need to do.
Are the LML mappings to other ontologies available on the Innoslate website?
If they're not, they should be. They might be in our Sharespace. If it's not, I'm not sure where we'd have it. So if you're not familiar with Sharespace, that is something let me introduce you to. So Sharespace, if you come to our innoslate.com page, you go to resources, there's a thing called Sharespace here. So you go to Sharespace, and there's a lot of information here and available. We've parsed a lot of documents. We're building models, and we want you to give your own contribution. So if you'll send it to us, we'll check it out, make sure there's no malware in it before we upload it, and then we'll upload it here and add it to this collection. But we have quite a bit of material here for that purpose. No, don't know that we have publicized the actual mapping. So again, if there's something specific you'd like to see, I'd be glad to see. Oh, I'm sorry, we do have an OWL file though. There is an OWL file associated with it, and we can send that to you. It's supposed to get posted up on the LML website, but I don't think it's been posted yet. Look real quick here. Is there another question?
No, that's going to conclude the question and answer portion of the webinar.
Oh, okay. Are we at the point? Anyway, so I think if you come over here to the LML website, I forget where the OWL file is, but take a look and look around for the specification, probably. Yeah, the OWL file, so coming soon, okay? It's been coming soon for a long time, so I've got to see if we can get that uploaded there. Okay, well, thank you all very much.
Yep, thank you, Dr. Dam. For more resources, we encourage you to visit our website and our blog, as well as connect with us on social media through the Innoslate user group or through Twitter using the handle @Innoslate. That concludes today's presentation. Thank you again for your attendance, and we hope to see you again at our next webinar. Please enjoy the rest of your day.